I thought I'd just start by talking a little bit about the Society of Light and Lighting. Are you all members, first of all? Can I have a show of hands? Are you all SLL members? Okay. Are you all CIBSE members? Right. Okay. So, Jim, you and I have got a task this evening before everybody leaves. So there will be a net at the door. So just to plug the Society of Light and Lighting a little bit, well, who are we? Well, believe it or not, but we're over 100 years old now. So the Society of Light and Lighting was originally founded back in 1909 under the name of the Illuminating Engineering Society. And through all that time, we changed names, we've regrouped, but we've been the authority on light. We are the place, we are the home for lighting people. So if you have a lighting interest and you're involved in lighting in your day-to-day jobs, then it really is worth becoming a member of the Society of Light and Lighting for a number of different reasons. What do we do? Well, we do a lot of things, but the core backbone of what we do as a society are our publications and our knowledge. There are thousands of years of combined knowledge across our membership and across our executive. And of course, we're most known for the Code for Lighting and the lighting handbooks, the staple tool, I think, in any lighting designer's toolkit. And of course, if you need further guidance, then we've got the lighting guide documents to go onto as well, which really then goes into depth detail about certain aspects of lighting. We also have lighting research and technology, and this is an incredibly valuable element of the Society of Light and Lighting. It is the world's renowned international lighting journal, and we do 8 editions a year, or we're starting from this year doing 8 editions a year, and there's some really good stuff in here, some really good papers. The technical and publications team are inundated with lots of really good research, and of course there's loads going on at the moment, research into lighting, and of course as a member of CIBSE and a member of SLL, you get access to this and you can read through them. So if you've got particular problems with things, then it's always good to have a flick through this, because there might be some answers in some of these papers that you need. We also do lots of events. I won't cover them all, but Ready Steady Light is one of the, I guess, one of the most fun events that we do through the year. Any of you that have not done it, then I thoroughly recommend recommending it to you or to your colleagues. And basically what we do is we have a great evening of lighting up some buildings. So we get a load of people together, we put them into teams, we throw some lighting kit at them, we give them a timeline and tell them to go and make some artistic effects. And some of the outcomes are really fantastic. And what we do is we then go around and judge and award different prizes and different awards for the creations. And it's just a great night. You only get a few hours, so the pressure's on. We make it all safe with the electrical connections and so on. This year, closer to where we are, then we undertook a major project called Night of Heritage Light. So this was to coincide with the UNESCO International Year of Light. So we wanted to mark this occasion, and we took on the audacious plan of lighting 9 UNESCO World Heritage Sites for just one night only. So you can imagine the mammoth organisational task that this took to get designers involved, to get planners involved, to get equipment involved, and then just do it for one night, but we did it. And this is some of the pictures here of what we created in one night. And if any of you are Twitter followers or Facebook followers, then this night really was just absolutely alive in terms of what was going on. A real great lighting community feel, everyone coming together. And also, the main point of this is, of course, getting across to the wider public the importance of light and appealing for people to get involved. So some of the scenes that we created were really, truly fantastic, and you'll see more about this in the SLL publications going forward from here. The Masterclass series is, again, another major event that the SLL organised. Has anyone been to the Masterclass series? A couple of people. Okay, good. So we're keeping this going. We keep it up for refreshed and updated every year. This year's topic is called Inside Out, Light and Architecture. So we're focusing on light and architecture, both inside buildings and outside buildings. The local event has unfortunately already gone. It was in Cardiff, I think, a few weeks ago or a few months ago. But those are the dates for the remaining ones. So if any of you are travelling around the UK and you fancy hopping on one of these, then it really is worth it. It's a great day. It's all in combination with our sponsors in partnership. Without these guys, then we wouldn't be able to put this on. They put the speakers forwards. All of the papers are peer reviewed. It's a great day of learning. Lots of the latest topics and lighting issues discussed at this day, and usually a damn good lunch as well. The same goes for sustaining members. Then again, a lot of what we do couldn't be done without these guys supporting us. These guys really support a lot of our events like Ready Steady Light, and also events trying to get young people into lighting. So again, without these guys, then we wouldn't be able to do a lot of this. So that's my plug with the SLL over. Let's talk about emergency lighting then. So emergency lighting, of course, is a very important aspect of all buildings, but quite often it's the second thing that's thought about. We focus on the mains lighting, we focus on the style and aesthetics of luminaires, and emergency lighting is quite often an afterthought. I think that's common practice throughout the world. So tonight's presentation actually focuses on the requirements in the UAE. So a lot of specifications come out of UK and Europe for projects in the UAE. And the UAE really do have quite a strange way of approaching emergency lighting. So hopefully tonight I'll discuss some of the issues, I'll run through some of the things, maybe clear up a few queries, and I'll take some questions at the end. So the agenda, let's take a look at what the UAE emergency lighting requirements are. We'll then take a look at emergency systems and luminaires, emergency lighting design, and then we'll finally end up with some approved products. So let's start with emergency lighting requirements. So what's the driver in terms of the code of practice in the UAE? Well, there's this document, the UAE Fire and Life and Safety Code of Practice, and there are 19 chapters to this. And trust me, if you read all of them, you really will be asleep by the time you get to chapter 2. But chapter 5 and 6 deals with exit signage and emergency lighting. So these two chapters focus on here. So tonight's presentation really sort of focuses on chapter 6 and the guidance that's given in there. This is the tricky bit. It's a mixture of British, European and American standards. So it's almost like someone's taken, well, that looks quite good in American standard, I'll bring that in, and that looks quite good in the European standard, and I'll bring that in. So it doesn't make particularly easy reading, but nonetheless, that's where we are. So it is a combination of many different standards that are already out there. And I think one of the other important things, and I'll cover this a little bit later on, is that all emergency lighting products require civil defence approval. Without that, then they will not be accepted into a building, but I'll cover that a little bit later on. So, emergency lighting, what is the point of emergency lighting? Well, of course, it's to facilitate safe exit, so people can get out of the building quickly and safely in the event of emergency or a mains power failure, to allow potentially dangerous equipment, particularly in industrial environments, to be made safe before those people evacuate. And in many cases as well, it's to allow fire wardens and the fire teams to be able to search the building and check for any missing people. So emergency lighting really does have quite an important role. The UAE Code of Practice is quite clear. It says that you must indicate clearly and unambiguously the escape routes, provide illumination along such routes to allow safe movement towards and through exits, to ensure that fire alarm core points and firefighting equipment is sufficiently illuminated so people can readily locate that as they exit the building, and permit operations concerned with safety measures inside the building. So the UAE code is quite clear there in terms of what you've got to achieve, but how do you actually achieve that? Well, if we start to break emergency lighting down, then essentially we have two forms of emergency lighting. We have standby lighting, we have escape lighting. Now, standby lighting isn't covered in the UAE code, but standby lighting is, of course, where you have a UPS supply or a generator supply that's supplying 100% of the power to the luminaires, so all of the activities can carry on if mains fails to the building. When we then start to look at escape lighting, then we can start to break it down a little bit further. So we've got escape route, open areas, and high-risk areas. And this is where we start to put a little bit more meat on the bones now in terms of what the UAE code requires. So along escape routes and corridors, anywhere where people are going to be sort of joining the flow to get out of a building, then we've got to achieve 10.8 lux average and 1.1 lux minimum. So, of course, this is quite a lot higher than what we're used to in the UK. And, of course, a lot of this is driven through the American standards. There's also a uniformity requirement, 40:1, so maximum to minimum. So we must make sure that the high and the low spots, the contrast between those isn't too great, so we have visual continuity as people escape through the area. For open area lighting, then this is usually deemed an area that is over 60 square meters or has an associated risk with it. And again, the light levels are the same, 10.8 lux average and 1.1 lux minimum, and the same uniformity requirement. And it's usually reasonable to exclude a half a metre border around the outside, just like we would with the UK standards as well. As we go into high-risk areas, then this really does require some extra thought and attention. In most cases, particularly in industrial areas, and of course out in the UAE, there is a lot of industry, a lot of very dangerous processes out there. Then these need to be made safe before people evacuate the area. And then, of course, as people work their way through these spaces, then it's got to be safe for them to do so. So the illumination levels step up a level. So we're now looking at 10.8 lux minimum rather than an average. So again, we're starting to see quite high light levels. So in most cases, you will need to probably look at a central battery system of some sort to be able to provide those kind of light levels. I'll mention that in a second. Now, the UAE code does reference certain areas where high-risk lighting is needed: kitchen, plant rooms, areas of refuge, first aid rooms, fire control equipment rooms, control rooms and CCTV rooms, etc. But we're not limited to those areas. So, we still need to think about the risk in certain areas and where we might need to extend high-risk emergency lighting. We must also ensure that all the points of emphasis are covered. So the UAE Code of Practice does reference 5266 and EN 1838 as suitable documents to also reference. So exactly what we're familiar with in the UK would apply to the UAE. So that each flight receives direct light, changes of level, changes of escape route direction, intersections, first aid points, call points, firefighting equipment, exterior areas immediate to the vicinity. So as you come out the exit door, then you've got to have an emergency light outside the exit as well. Moving stairways and walkways, which there are quite a lot of in the UAE. Motor generator and control rooms, lift cars, covered car parks. This is quite an interesting one. There's a lot of covered car parks in the UAE for obvious reasons, and these need emergency lighting, particularly if they're underground. Areas of refuge, toilet facilities, and of course anything else that might be deemed under risk assessment in the building as well. So as we're planning our lighting designs, then we must make sure that all of these areas are catered for in the design process. The UAE code, again, is quite clear that the emergency lighting must be provided for 3 hours. Again, nothing new, very similar to what we are familiar with. However, what is different is that after 1.5 hours, you have to hit at least 60% of your designed light levels. So if you're designing to 10.8 lux average, then you can go down to 6.5, and obviously 1.1 lux minimum would become 0.65 lux. I can't imagine anyone actually going around with their light meter after 1.5 hours and measuring these light levels. But nonetheless, that's in the code there. I think it's not really needed these days, because most manufacturers' lumen outputs are typically take into account battery degradation, lamp degradation, etc., etc. So the lumen outputs that you designed with are at the end of a 3-hour duration, at the end of life of the battery, etc., etc. So you should never really get into that situation anyway. But just be aware of it, because you might have to come across it. Hotel rooms and suites also need to be covered. So again, in the UK, we don't need to worry about this. But out there, it's quite clear that you need emergency lighting in those areas. And it's also quite clear and makes special attention to buildings where many people may be in attendance. So I think this is sort of an indicator that extra thought needs to be given to these sorts of places where lots of people can congregate. So in terms of emergency lighting design, etc., then it needs to be very robust and rigorous. Again, we're all very familiar with this. Emergency lighting should be fed from the local lighting circuit. Of course, it goes without saying. And again, the UAE code is very clear on that. And this is where we start to get a little bit strange. So when it comes down to testing of emergency luminaires, then it makes these following statements. So emergency luminaires shall be automatically monitored and tested through a dedicated control system. So where we're putting emergency lighting into buildings, it must be auto-test. It must be self-test. But talking to a lot of people out there, if you've got a fairly small building, then they're clearly not going to invest in a self-test system, and it doesn't happen in quite a lot of cases. But nonetheless, it's there. So just be aware of that. I think what it's trying to drive is that certainly in large buildings, then this is desirable. And where you've got an automatic test system, then it needs to be interfaced with the BMS. Now again, it says it should be interfaced, but it doesn't say what should be interfaced, or how much should be interfaced, or what the interface protocol should be. It just says it should be interfaced. So that's a little bit open to interpretation. But talking to just going back a stage, talking to some of the consultancy practices out there, then every single emergency lighting design has to be approved by civil defence out there. So in a lot of cases, I believe what happens is that if you've got a small building, and it obviously doesn't make sense to put a self-test facility in, then you can have that dialogue with civil defence, and you can say, look, you know, my building's only got 3 rooms, I've only got 10 emergency lights, you know, I'm not going to be putting a self-test system in, and civil defence will make a judgment and instruct otherwise. And I think probably this is why they don't put too much detail in here, because civil defence have to approve every project, then you will naturally get into dialogue with them, and they will sort of steer you in terms of what they expect. So clearly, if you've got a very big building, then they're looking for a pretty robust and automated system, particularly in terms of communication. Whereas the smaller you go, then they may not be so bothered about that. But just be aware of that in there. Exit signage, of course, is needed to direct people out of the buildings. Not really anything different to what we're familiar with. It does say to ensure that escape routes are apparent from any location in the building. So if it's not immediately obvious where you exit, then you need a series of exit signs to be able to direct you out. They should be conspicuous, and we must consider smoke accumulation as well. So the mounting height of exit signs do come under scrutiny. So mounting them too high can cause some problems. So we do need to give that consideration. Where we are using exit signs, then it's quite happy to use either externally lit or internally lit. Just a reminder, then there is a limit on viewing distances. So if you're externally lighting the sign, then you can only realistically have a viewing distance of up to 15 meters if you've got a typical 150 millimeter high sign. Internally lit, of course, you go up to 200 times the sign height, so you can double that up to 30 meters. So just give that some consideration as well as you're working through the scheme. But again, not really different to the UK. Clear and unambiguous. I love this picture. I've got a few like this, but I think that's the best one. Which way do you go? So, of course, it goes without saying, with any exit signage, then it really must be very clear in terms of which way you exit out of the building. So let's move on to some emergency systems and luminaires then. So there's generally 2 available systems, a standalone emergency system or a central battery system. Just to go through the benefits and pitfalls of each. Standalone system, very easy to install. Batteries are local to the luminaire. You have great flexibility. You can move that. You can add more fixtures in. Maintenance costs are spread over a period of time, however, it can be difficult to achieve these higher emergency light levels. Where we're starting to talk about 10.8 lux average or 10.8 lux minimum, then from a local battery, then that can be quite difficult. Although I think we're moving into a time with LED technology, as I'll show in a minute, then we're sort of coming away from that. Central battery systems, obviously achieving the power that's needed is easy, so we can get high illumination levels. Generally, you can get a longer battery life from a central battery system, but it does need careful management of the battery temperatures. So quite often these cubicles will need to be climate controlled, very precisely controlled, and then yes, you can get some longer battery lives, but of course, as I put there, maintenance is required to achieve that. In a lot of cases, luminaires don't need conversion, so you can just hook those straight up. But increased complexity of wiring and cost, and there's a particular facility of the UAE code, which I'll mention in a second as to why that's prominent. Central battery cubicle needs daily inspection to make sure that it's in a ready state to provide emergency lighting. If one unit fails in a room, then that's probably not going to be a big problem in terms of the standalone system, but if your whole cubicle goes down, then you're in a bit of trouble. So it needs daily inspection to do that. And you can also have a problem with capacity. If you haven't got headroom in the system, then as the building changes and you want to maybe put more emergency luminaires into the building, then you might have a problem in doing that. Whereas with a standalone system, of course, you don't have that. So there are benefits and pitfalls to each, but the UAE code is quite happy to accept both systems. It doesn't particularly steer you down one route. Oh, I missed one there. Higher battery replacement costs, yeah. So of course, once those batteries do come to the end of life, then they're quite expensive, and it all comes in one hit as well to the end user, which may or may not be an issue. So when we start talking about standalone systems, then as I've said, they must provide 3-hour duration, they must be automatically monitored, and it says that the monitoring shall be at least for low battery, faults and status. That's all it says. So could be a little bit more detail there, couldn't it? But most systems will usually provide that as a basic. Central battery systems again provide 3-hour duration. Again, must be connected to an automatic monitoring and testing system. But it's this that can add to the cost. So it says that a cross-zoning arrangement must be used in the building. So any area must be fed from at least 2 emergency luminaires and from the 2 different circuits. So if one circuit is lost, you still have emergency provision in the building. So this is where the extra cost can arise in providing this cross-zoning arrangement, particularly when you're looking at armoured cabling from the central battery, and that's where a lot of cost can come into it. Product suitability, aesthetics I think really come into play with this. It's amazing how many of those fittings are used out there. So you've got these wonderful buildings, you've got marble floors and marble pillars, and the architecture is fantastic. You look up at the ceiling and they're just littered with those things. And it's just such a crying shame, it really is. So, I think we need to think a bit more about product aesthetics, and I think we are moving to a time now where, LED technology is becoming quite discreet. So LED technology is allowing us to produce small light fittings, more powerful light fittings, and of course has the long life and lower maintenance benefits to go with it. So we can use lenses to optimize the control. So particularly where we're looking at corridor applications, we can distribute the light down the corridor to use less luminaires. And we're starting to get the outputs now. We can easily start to achieve at least 300 lumens from a fixture, if not more, on special requests. And of course, typically you're looking at in excess of 50,000 hour life. So again, this can bring maintenance costs down. But it's really the size of these units that I think is quite important for the UAE market to fit in with their architecture. Okay, these aren't UAE buildings, but initial look at those pictures, then other than the big exit sign there, it's quite hard to see where the emergency lighting is. If I just ring them up now, then they do tend to blend into the background, whereas if I had a good old 8-watt lunchbox on the ceiling there, then of course they wouldn't be blending into the background so much. So do think about the aesthetics of the fitting, particularly for that market, because it can make a big difference. LED technology, again, when it comes to exit signage, I think this is the worst lamp ever invented, the 8-watt T5 lamp. In a maintained exit sign, you're looking at 4,000 hours, so you're going to have to change that lamp twice a year in a maintained fixture. Of course, with LED technology, then it's not so much of a concern, and I think we're all naturally migrating in that direction anyway. So in terms of inspection and testing, as I've already mentioned, with central battery systems, then we have to do a daily visual inspection to make sure that it's in an on-state. Of course, if you've got an automatic testing system and reporting system, then you don't need to do that. Monthly tests, we need to do a short duration test. So every month we need to energize the emergency luminaires and make sure that they strike correctly. And then, of course, every year we need to do the full 3-hour annual duration test as well. So again, nothing different there to what we're familiar with here in the UK. And of course, this is where it really does make sense for automatic testing systems. I can see why they're driving in that direction. So let's just take a very quick look at emergency lighting design. So the design process then, I won't dwell on this too much, but some of the things that we need to consider, well, we need to identify the building type, we need to understand what's happening in that building, we need to understand what the risks are in that building, just like we would with any project when we undertake emergency lighting. We need to identify the exits, the final exits and the safe areas. We need to identify where the escape routes are. We need to also identify the spaces that are greater than 60 square meters, identify the hazards, identify the points of emphasis, and then we need to start thinking about what kind of emergency products, how those products are going to fit into the space, and the aesthetics of those luminaires. Yes, in the plant room, a lunchbox type fitting is absolutely fine, but in some of the other areas, then maybe a more decorative product is suitable. We need to position the luminaires at the points of emphasis, so all of those areas that I covered earlier on, and then we need to add luminaires in between to achieve the emergency light levels that are required. We need to check glare and uniformity, and I think that this is quite important. I have a bit of a bee in my bonnet at the moment about glare altogether because I don't think anyone checks glare anymore. In fact, is there anyone in the room tonight that's done a glare calculation recently? Yes. Well done, sir. I'll shake your hand a bit later on. Not an emergency. Not an emergency, no. But glare, I think, largely is something that we're forgetting completely. And it is important, not just for standard lighting, but it is important for emergency lighting as well, particularly with some of these LED products and high output products. Then we can start to talk about quite high intensities from the luminaires. Now, I'll mention a bit more about that in a second. I think there's some other design considerations as well. The height and position of the calculation plane. Again, we might not be designing to floor level. We're moving to a time now where we need to start thinking about, well, actually, is it appropriate more to consider the light levels in a vertical surface, for example, or is it more appropriate, certainly in a high-risk environment, is it appropriate to think about the emergency light levels off the ground? So if you've got a particular process or machinery at machine height, well, there's no point in calculating 10.8 lux on the floor. It's worth considering where that danger is and the position and orientation of that. So I think we need to give that some consideration. Reflectances of the room. The UAE code, and this is a bit ambiguous, the UAE code doesn't make any reference to reflectances. Now, of course, in EN 1838, it says that we have to assume 0 reflectances in the UK. So we have to take worst case. So if someone comes along and paints the wall black, or if there's a lot of smoke build up in the environment, then of course you lose reflectances quite quickly. Talking to a lot of people out in the UAE, some people use 0 reflectances, and some people, to try and get the scheme through, carry on using reflectances in their emergency calculation. And I couldn't really get an understanding from civil defence either where they sit on this. So unfortunately, I can't really give you much of a steer on that. But really, we should try and work to worst-case scenarios and assume 0 reflectances. But when we're trying to achieve these light levels, then sometimes it can be quite difficult. But we should assume worst-case scenario. Maintenance factors. We calculate maintenance factors for standard lighting schemes. We need to consider it for emergency lighting schemes as well. So just coming back to this glare issue. So as I said, the UAE code does reference EN 1838. And there is a requirement there to meet certain glare limits. So for a ceiling height there of 2.5 to 3 meters, you can see that in open areas, there's a limit of 900 candelas from the luminaire, or 1800 candelas in a high-risk area. So again, coming back to some of these high-intensity LED products, and we do need to check this, we do need to cross-reference this, just make sure that some of these products are suitable. And what we can see is that depending on whether you've got a flat ground, or whether you've got some stairs, then the angles that this applies to the product changes. So these intensities only apply up to 60 degrees if you've got a flat surface, but if you're coming down the stairs, then it applies through 180 degrees of the luminaire. So do give that some consideration as well. The other thing is positioning of emergency luminaires too, and I've come across a couple of jobs now where they use these twin spot fittings and put them right over the door. And when you switch them on, you can't see the door. So we've got to think about where we locate these. And again, EN 1838 gives us guidance: 2 meters horizontally, 3.5 meters vertically outside that zone, so people can actually see the exit door. So we just need to give some consideration to that as well. Of course, twin spot's quite good for illuminating large open plan areas, which again we get quite a lot of in the UAE. 2 luminaires per compartment, as I've already said. So if one circuit fails, if it's a central battery system, or if one luminaire fails as a standalone system, then there's always a backup there, not plunging the whole area into darkness. And let's finally just take a look at some approved products. So this is quite an important process and quite an important part within the UAE, because all life safety, fire safety, and emergency services shall be listed, approved, and registered by the Civil Defence Ministry. So they will not allow any emergency lighting product that hasn't been approved by them to be used in a lighting scheme. And it's quite a rigorous process. So out of the 7 emirates that are out there, they all have their own different requirements. They all have their own civil defence authorities, if you like. And you, or a lighting manufacturer, will need to seek approval from each of those civil defence authorities. So just because you get your product approved in Dubai, under Dubai civil defence, doesn't mean that you can use it in Abu Dhabi. So it's quite a process to go through. But effectively, what a lighting manufacturer is seeking is a civil defence approval certificate. And basically, one of these. And what this means is that the Civil Defence Authority recognise the product, they list the name of the product, they list the part numbers of the product, and that gets entered in onto a list. I did some research to see if you could find this list online, but it doesn't exist, believe it or not. The list does exist, but you've actually got to go into the Civil Defence office and ask the receptionist, and you'll get a printed copy, believe it or not. But it's not posted on online anywhere, which is a little bit of a shame, particularly for designers over here. It's not exactly easy to go and pop into the local civil defence office, is it? But nonetheless, this list does exist. So this is what we're targeting. We're looking to get one of these. The process to get it is both costly and time-consuming. We've worked with the British Standards Institution and the Kite Mark certification scheme. We actually pioneered the process to try and get through to civil defence approval. And there was a lot of toing and froing going between civil defence and between BSI. And finally, we'd laid out the results. We'd written in detail what everyone needed, and we got the product approved. So Philip Payne, a brand of our company, is available and has been approved in a number of those areas. But it is quite difficult to do that. So just be aware that you can't just use any lighting manufacturers or emergency lighting manufacturers' products. They do have to be off the approved list. Having said that, walking round, I did see some products that I highly suspect that aren't on the approved list. But hey, that's the way the industry always works, doesn't it? But do be aware of that. So that, ladies and gents, or gents, brings me to the end of the presentation. I hope that was of some use. I hope that was informative. I'll burn everybody's retinas now by the lighting. Does anybody have any questions? Yes.
Yes, now it's not up, out, down. Okay, what? Down, but what?
Very good question.
Consider it's supposed to be
yeah.
easy to recognise and everybody down.
Yeah. Um, the as far as I'm aware, that there isn't any prescriptive nature. It's very different to the UK. You're allowed to use text, which you can't use here, so you can use the word exit. You're allowed to use a running man, and you've got to use an arrow if you use a running man. I haven't come across the issue of up and down yet out in the UAE, so to be perfectly honest with you, I don't know how to answer that question. And I dare say that their view will probably be to fall in line with everybody else. But I might have to take your contact details and do a bit more probing on that and come back to you on that if I can. But yeah, it's certainly becoming an issue in the UK now, that isn't it, with the arrow up and the arrow down. But I haven't come across it out there yet.
Which you mentioned about risk assessment. Who carries out the risk assessment?
I think that is a combination of the of civil defence, of the lighting design or the consultancy practice, the architect, and the planning and developers, exactly the same as it would be in the UK. Obviously, over here we have the RRO that's driving that, and there isn't anything like that out there. Really, civil defence will drive you in terms of emergency lighting. If they are not happy with what you've submitted, they will tell you about it. So they really are sort of overseeing everything, really. Sorry? Yes.
Yeah.
We do, yes. We have to go through the whole process again. Yep. It's quite a detailed, and I actually applaud it, because what they're saying is well, we're not going to accept any old junk. You know, we want a proper fitting, and I think that's quite right, really, isn't it? You know, they're defending their market and their area, and you know, being out there, then they're susceptible to all markets, aren't they, and all sorts of different types of quality products. So I think that's the right thing to do. It just gives us, the UK lighting manufacturer, a bit of a headache. Yeah, it's because what they've done is they've adopted the American standards, and American standards work in foot candles. So for emergency lighting in the US, it's 1 foot candle, and if you equate that into lux, it's 10.8 lux, and that's that conversion. So the NFPA standard drive that, which is why I say it's a strange mix between NFPA, EN, and BS standards, which complicate things.
Cost.
Not that I'm aware of, no. As a part of the planning process for the building, then the emergency lighting scheme will be submitted as a part of approval by civil defence. So I don't believe that there is so. In fact, that's a very good question. I'm not aware of one, put it that way. That doesn't necessarily mean that there isn't one. The lighting design or the product? The design. I think it depends on the type of project and the scale and the importance of it. I've heard of situations where it can take many months, and then I've heard of situations where it's been quite quick. So I think it sort of depends, like anybody, on the workload that the particular departments have at civil defence, and also how that impacts in other things that are going on in that project as well. So I think it varies, basically. On the exit sign face? That's a very good question. It isn't, no. It isn't specifically mentioned in the UAE code in terms of how much you should achieve on the exit face. But as I say, it does reference 5489, EN 1838, and 5266. And I'm just desperately trying to think of what the lux level
So there is,
Jim, can you help me out there? It's just suddenly gone.
There is a figure.
There is a figure, and it's just completely gone out of my head. But there is a certain figure, but it's covered in the British standard. The UAE code doesn't give any set figure.
I guess for the self-illuminated design,
Yeah.
they are approved.
Yeah. Then they will be designed to again achieve the candela limit via EN 1838. Yeah.
Something you've got to realise in this country as well, we're doing most of the time. Like you mentioned on there about bar equipment, good middle design, you're like clear this corridor, you have no idea where that is.
Yeah.
So you put that in at a later date.
And this is
finger there and guess.
well, this is it, isn't it? And this is where a collaborative approach is needed between the emergency lighting planners and the lighting design engineers, etc., etc. And it's an age-old problem throughout. I'm not clear on the exact process of civil defence, but I would imagine that you will have to submit your emergency evacuation and emergency layout plan within the building as well as your emergency lighting. I've heard that they do look to see the two overlaid. So you're going to have to talk to someone as a lighting design engineer at some point to understand where your fire extinguishers are, where your core points are, etc., etc. So you're going to need to do that. Okay. Thank you very much for your time.
Yes, thank you very much.